Hello. Today we're going to use tape diagrams to show the commutative property of multiplication. Now, often you hear the phrase when associated with commutative property of flip facts or they're exactly the same. So we're going to use tape diagrams to find out what is exactly the same, so what part of that statement is true and what part of that statement is not true. So let's look at the statement 2 multiplied by 5 equals 5 multiplied by 2. So this is a common example of the commutative property. So all I changed was the order of the factors, and we want to prove if this statement is true, is 2 multiplied by 5 truly equal to 5 multiplied by 2? So let's use tape diagrams to model each of these expressions. So 2 multiplied by 5. So if I'm making a tape diagram showing 2 multiplied by 5, the first number tells me the number of sections or units in my tape diagram, and the second factor tells me the size of those units or sections in my tape diagram. So 2 multiplied by 5 would be 2 units or groups of 5. So drawing my tape diagram, breaking it into 2 equal groups. Now I know the value of each of these is 5. And 5 plus 5 is 10. So this shows that 2 groups of 5 equals 10. So this would be the model that matches the expression 2 multiplied by 5. Now let's make a tape diagram showing 5 multiplied by 2. Well, the difference in this expression is it is 5 groups of 2. So my tape diagram has to have 5 equal parts, and the value of each of those parts or sections is 2. So I have my 5 equal parts, and I know the value is 2, and I could continue to show that. I wouldn't have to once I show you that the value of one section, since they're equal, the value of all of them would be 2. And then I know 2 plus 2 plus 2 plus 2 plus 2 is 10. So this tape diagram demonstrates that 5 groups of 2 is also 10. So when I'm looking at these tapes, let's talk about what the tape diagram proves is true about the commutative property and what it doesn't prove. So first, if you look at our tapes, 2 multiplied by 5 is equal to 10, and 5 multiplied by 2 is also equal to 10. Well, since each expression is equal to 10, then I know that 2 multiplied by 5 is also equal to 5 multiplied by 2. So what this shows is they are equal because they're both equal to 10. Both expressions show the value of 10. Now, what it does not show is they are not exactly the same. You can tell with the tape diagrams. So when I'm looking at this tape, this is showing 2 groups of 5. This tape here is showing 5 groups of 2. Where this would differ is, for example, in a word problem. A word problem, these two models would demonstrate completely different situations. So for example, I like the game of basketball. So the first model, the yellow model, shows that 2 groups of 5. This would be a standard basketball game. 2 teams, each with 5 people on the court. The second model would be an example of playing 2-on-2. So 5 teams of 2 are playing in a tournament. So these are 2 entirely different situations. What would be the same in both of them is they both would involve 10 players. So this shows the commutative property shows the products are the same. So 2 multiplied by 5 and 5 multiplied by 2. So the order does not affect the product, but it can affect the situation. Thank you.